My name is Thomas Bartscher and I'm working on the Poslin programming language. Today I'm going to show you how it works. Yeah, Poslin works with threaded code. You can look that up on Wikipedia. I'm not going to explain it, just this much. That's got nothing to do with multi-threaded programming. So, yeah. To show you what this means, I'm going to construct a thread and yeah. A thread in Poslin is basically a binary tree, and this thread, you can see it has this front and this back. So when a thread gets evaluated, it's so that first the front gets evaluated and then the back gets evaluated recursively. That's the easiest way to put it. So I'm going to show you that with a Poslin stepper. You can see now the program counter. Here it shows the return stack, the paths, which I will be coming to later, the program counter, and the current stack. You see the program counter is pointing towards a elementary instruction, which is named by the exclamation mark. This instruction pops off the top of the current stack and points the program counter towards whatever it popped off. That is, in this case, this thread. Okay, so what happens now is that the interpreter looks into the front of the thread and based on what it finds it decides what to do. This is a constant thread, signified by this sharp sign. This the interpreter will just push whatever is in here onto the current stack and then point the program counter towards the back of the thread it's currently pointing to. So the 2 gets pushed onto the stack and program counter is pointed towards this part, as you can see here. Now it encounters this path, this elementary thread, which is just basic addition, which will pop off these 2 values of the stack, add them and push them back onto the stack. Since now the program counter is empty and the return stack is empty, evaluation terminates and we've got our result. That's an easy example. To give you a more complex example, which also makes use of the return stack, I'll have to construct a bit more complex thread. So once again, this thread can be understood as a binary tree. Here's its front and here's its back. This might not look like a binary tree because it's printed in a way that makes it look more like a nested list, but it is a binary tree. This is the subtree, the back subtree, which again can be divided to the front and the back and so on. So let's evaluate it with a stepper. And one thing in advance, the stepper is not made for teaching purposes, but for debugging, of course, and as such it jumps over some steps which are of no interest when debugging. So, for instance, as you will now see, when this points the program counter towards this thread, it will actually not show the part where the program counter points to this whole thread, because when the first part of a thread, the front part of a thread, is itself a complex thread, only one thing can happen, and that is that the program counter is pointed toward the thread that was found, and the back of the thread is pushed onto the return stack. Here you can also see that this is actually really a binary tree. Here's the front, here's the back, and yeah. So what will happen now is that this will get evaluated just like we've seen up here. Push the 3, which is constant, evaluate the multiplication. Now, once again, the stepper jumps over one step, that is where the program counter is empty, or rather pointing to the no op, the operation which does nothing. And this is of course of no interest to the programmer when he's debugging, so it's not shown. But what happens in that case when the program counter points to the no op, the interpreter just pops off the return stack and points the program counter to the retrieved value, which is, well, this thread. And this gets evaluated just like normal. We push the 4, the 4 is popped off by this, the value is negated, and the negated value is pushed back onto the stack. Now the addition will pop off 9 and -4, add them, and push the result back, which is 5. Okay. Now on to something you might already have realized. If you look at this, you will notice that when I put in something like this plus was not evaluated immediately. So just to show you, I input this and the plus just gets pushed onto the stack like everything else. To evaluate it, I need to input an exclamation mark to point the program counter towards the thread associated with the plus symbol. Now the exclamation mark itself is also only a symbol, and that's all what the path is all about. The path is a stack of dictionaries, or these dictionaries, and what's of importance to us right now are these two slots in that dictionary. That is the slot named op and the slot named in. Op is for operation, in is for immediate. Now these things here are called bindings. These are basically places, the only mutable objects in Poslin, whose only job is to be mutable. Well, and these contain, well, in case of the immediate slot, there's a set stored in here, a set that contains symbols. When the reader of Poslin encounters a symbol token, it looks up the corresponding symbol in the set that is stored inside here. And if it is found, that means that the symbol is immediate. If it is not found, it is not immediate and just pushed onto the current stack like everything else. So, but if it is immediate, it gets looked up in the dictionary that is stored in here, and this dictionary just maps symbols to bindings of threads, and the thread that is found for the symbol that's looked up here, because it was found here, is then just what the program counter is pointed to. If this seems a bit roundabout, let's consider what's happening here. The one is tested, is it a symbol? No, it's not a symbol token, so the number just gets that it is just pushed onto the current stack. The plus is a symbol, it's now not found here in the set that is stored here, so it also just gets pushed. The exclamation mark is found in here, so it's looked up in the dictionary that is here, and the thread that is found is put onto the program counter, and the interpreter is started so that whatever the corresponding thread does gets evaluated, which leads to this being evaluated to 7. So when yeah, so what is this good for? Um, you probably have heard, if you ever programmed before, of something called scope. So I'm gonna show you a simple example that is maybe not so obviously about scope, but well, the principle will get obvious. This is an immediate symbol which opens a new local stack. You can see on the stack we used before there's a 7, the new stack we just opened is empty. To show you what that did, I'm going to do this. That is, I'm going to call the no-op in stepping mode. So yeah, you can see the path now has 2 dictionaries on it, and in the top dictionary the stack slot contains a different binding. Well, this stack slot contains in this binding exactly the stack you see here. This is really a stack that is saved in this binding. That is, we have now a different binding with a different stack inside here. And this stack is always retrieved. There is a stack that is displayed here, and the stack that everything happens on is always taken from the top dictionary in the path. So now we're operating on this stack. So we can, I don't know, push some numbers, maybe do some calculation, whatever else you want, and then we can close the stack. What this does is to pop off this dictionary from the path and retrieve the value that's stored in the binding in here, and pushes it onto the stack that is saved in here. So now we're back in our old stack with this new element we just created in this way. So if you do something like pushing a new dictionary and then exchanging, for instance, what's saved in this slot, you can make local operations available which you can which are shielded from outside influence. You can create local variables or change the immediateness of certain values. For instance, there is an operator which makes every operation immediate, which works by making by pushing a new dictionary onto the path that makes puts in, the symbol of every operation into the immediateness slot. And you can also see here is a different binding than here. So this just pops off the top dictionary and throws it away. So now again we can see on the top of the path is the old dictionary. So that's basically it for today, and I hope you enjoyed it. Thanks for watching.